how to produce a confidence interval for a mean, but next we need to look at how to produce a confidence interval for a proportion. If we're doing a political poll or a calculation of a mortality rate or the percentage of a population that does something, then we're talking about a proportion, and we need to be able to produce a confidence interval on the basis of a sample. So let's look at an example where we look at a poverty rate. So the idea here is that we're going to look at the poverty rate in New York State. Now, this is information for which we have really good global data. We actually have really good data about the entire population of New York State. But let's assume for the purpose of this problem, that we don't have information about all the millions of residents, that we are only able to do a sample. And let's say, for the sake of argument, that we're able to do a sample of 1,000 residents. So we sample 1,000 residents, and by whatever definition of the poverty line we use, we find that 150 are living in poverty. So right away, we get a proportion from this. We have 150 out of 1,000, and that's the proportion below the poverty line. And that is the proportion, and so we're going to call that P. But let's be careful here, because that is a sample proportion, and the appropriate symbol to use for a sample proportion is p hat. So that's our sample proportion, and now we're faced with a problem of inference. Should we infer that of all of the people in New York, exactly 15%, so this works out to be exactly 15%, that's 0.15. Should we infer that exactly 15% of the residents of New York are living in poverty, or should we infer that it's about that? And if it's about that, then, well, how close is it? So that's the question of the confidence interval. We need to find the confidence interval. Now, the confidence interval is based on the standard error, and so we need a formula for the standard error of a proportion. And that formula looks like this. So let me copy it here. It appeared in the last video, but only very briefly. So standard error of a proportion. This is very different from the formula sigma over the square root of n. That's the formula for the standard error of a mean. We're not going to be using that here. We're going to be using this formula. The standard error of a proportion is equal to the square root of p times 1 minus p over n. Now, you might think I've forgotten the hats on these p's. This is the correct formula for the standard error of a proportion, and it's based on the population-wide proportion, which is p, not p hat. Of course, we don't usually know the population-wide proportion, and so we have to do the next best thing. And the next best thing we can do is plug in the value of p hat for p. So we don't actually literally calculate the standard error using its formula. We estimate the standard error using the best thing we have, which is p hat in place of p. So in this example, we plug this in. So the standard error is equal to 0.15 times 0.85 divided by 1,000, and then square root of the whole thing. And then whatever calculator system you're using, you can find that that's equal to approximately 0.0113. So that's the standard error for the proportion. Now, this proportion is very naturally read as a percentage, 15%. And this can be read as a percentage too and compared against it. This is basically 1%. And that means that we are probably off by about 1%. The standard error in this measurement, because we've only sampled 1,000 people, is going to be off by about 1%. If we sampled more people, then we would probably measure more accurately, and then the standard error would be a smaller number. But if we sample only 1,000 people, then we're likely to be off by about 1%. And so that's the basis for our forming the confidence intervals. Now, there are, of course, 3 confidence intervals that we've learned how to produce, and I want to at least refer to all of them, but I want to only use the one that's typically most important, which is the 95% confidence interval. When we use the 68% confidence interval, we take the measured value and we add and subtract the standard error, and that would give us approximately 15% plus or minus 1% here. If we use the 95%, then that would give us the measured value plus or minus twice the standard error. And if we use the triple the standard error, the 99.7% confidence level, then we would get p hat plus or minus 3 times the standard error. As I mentioned before, this 2 is a little bit of a fudge. The perfect number to put here is 1.96, but let's not complicate our lives. So this is the one that we will most often use. And this is about 0.15 plus or minus approximately 1% times 2. So that's 2 times 0.01, which is about 13 to 17%. So the right conclusion here, so let me give some accurate numbers there in order to be precise. So to be precise, we have 0.15 plus or minus twice 0.113. And so we have the lower number is 12.74%. I'm still rounding off slightly, but much less. And the upper number is 17.26%. So that's the right conclusion set of the population of New York live in poverty. So that's the right conclusion from this small study. You see, we've only sampled 1,000 people, and so we're only getting limited information. And so we can't necessarily trust our result exactly. And that's what the confidence interval is illustrating to us. We can say with confidence, that is with 95% level confidence, that somewhere between 12.74% of the population and 17.26% of the population are living in poverty. We can't say definitively that, say, more than 14% of the population is living in poverty. We can't say that because, you know, it could be slightly less than that. It could be slightly more than that. Now, this is our first example of using a confidence interval for a proportion. Now, the next example in the next video, we'll look at a confidence interval for a proportion twice over, once for New York, once for Pennsylvania, and then compare them to ask, do we say with confidence that one is greater than the other?